I'm Scott Griffin, and today we're going to take a look at hash maps, as I find these to be one of the more confusing things for beginners to understand, especially when you start iterating over them or trying to build them from other collections. So we're going to start by looking at hash maps on a conceptual level and then build our fundamentals from there so that when we look at the more confusing things, we'll understand what's going on. So to start out, I have an array list holding strings. Now you might notice that this is not a hash map, but I want to point out something first. When I run a get method, I pass in an index. Now this allows me to access one of my individual values in constant time. So let's go ahead and print this out to prove that it works. And we should see that this is going to print out Lena, because this is going to my array list called names list, saying get me whatever you have at index 4. Get me the value that you have at index 4. So this returns this value. The takeaway here is we are accessing individual values using the index in constant time. And that's really powerful because I can access any individual value in my list in constant time, no matter how big my list is. Now the caveat is I have to know my index somehow, and that's not really a reliable way to identify one of my values, because if I were to remove a value at a lower index, everything is going to shift. So this is where hash maps really shine. Hash maps allow us to access our values based on anything rather than just the index. So the syntax looks like this. Just like with our list, we have to define our type of objects we want to hold as the values. So let's just put a string. But we also have to define the type of key. So I'm just going to use string for now. And this is going to be a hash map. So map is our interface, and HashMap is the most commonly used concrete implementation of that interface, just like we have list and array list. And importantly, this doesn't have to be string. This can be any object type we want. So let's say I want to track the number of dogs that each person has in the room right now. I currently have one dog in the room right now. His name is Dresden. So I'm going to actually have the keys be a person's name and the values be an integer. All right, so to add values into my hash map, I use a put method, and I have to define the key, which I'm going to put as Scott, and the value, which right now I have one dog in my room, and this adds the value to my hash map. Let's go ahead and do a few more. All right, so I went ahead and added some values, and notice how similar it is to this list add method, right? Instead of add, we use put, we define the key and the value. It's actually very similar to if I were to add something to my list, and I were to say, I want this to be at index 2, and now the value is going to be Dresden. The first argument is defining the index, which for the list is kind of like the key, and the second item is defining the value. Just like in map.put, the first argument is defining our key, and the second is defining our value. And notice that, of course, our keys are strings, and our values are integers. So to access one of these values, just like I would say names list get index 4, I'm going to say map.get, and instead of passing in an index, I can pass in any one of these keys. So let's go ahead and print this out. Let's just get rid of this print statement. Run this, and we'll see 0 because Lena has 0. So just like our list method takes in an index as an argument and returns the value at that index, our map.get method takes in a key and returns the value at that key. So both of these collections can access their values in constant time. In the array list, it's using some memory math to figure out the location of index 4, whereas the hash map is using hashing. So if you're familiar with sets or something else that uses hashing, you'll know that there are two things to keep in mind. One, there's no particular order to the things I've added to my hash map. So let's go ahead and print out the whole map, and we will see that it's not printing out in the order that I put them in. In fact, there's no discernible order. This isn't even alphabetical order. This is just based on a hashing function. And if I were to add more values, this order would change. The other thing is you cannot have duplicates. So if I were to add another Scott and say this time I'm going to add 10 dogs to this is going to replace this entirely. Like we won't see two different Scott keys with two different values. So let's go ahead and run that, and I will prove that to you. And notice that there's only one Scott. Now, one of the things that I found really confusing at first is how do I say increment the number of dogs that are in the room? Like I can add this key and this value, but what if I said, oh, another dog just walked in the room. Let's add one to it. So let's say Wells went out and got a new dog. First thing I need to do is get the current number of dogs in the room for Wells. So let's do a map.get and pass in our key, Wells. So this, of course, is going to go to our hash map. So get me the value at the key Wells, give that back. This is returning an integer, right? We have a reference to this integer. Let's go ahead and store that in a variable for now. So num of dogs. And of course, we're saying that one more just walked into the room, so let's increment it. And then all we have to do is put it back in the map. So we say map.put Wells, and we can add our num of dogs into the map. This works again because the keys have to be unique. Even though I already had a Wells 399 and now I'm adding a Wells 400 into the map, it's going to overwrite this key entirely. So if I were to print out the map now, we would see that Wells should have 400 dogs in his room. There you go. And just for fun, I made a HashMap printing class that will help us read these maps a little bit more clearly as they get more complicated. It's going to look something like this. Here's our keys, here's our values, and we'll see more of that in the future. In a moment, we're going to look at how to iterate over hash maps and how to build them iteratively. But before we do that, I want to take a look at the anatomy of a hash map because I think this is where a lot of the confusion lies. So the map manages a couple of different views of itself for us. For instance, we can say map.keySet, and this is going to return a set of string. Now, you might notice the word key in there. That's because this is returning the set of our keys, which just happen to be of type string. Okay, so this is a set of our keys, which I've highlighted over here. We can also, of course, pull out our values. Now, this is not a set because, unlike our keys, values do not have to be unique. So instead, they are of type collection, which you may not have come across a whole lot yet. It's essentially like a base collection class that all of the other collections in Java are inheriting from. Honestly, this is the only time I've actually used collections when accessing the collection of these values. So that's taking all of these. So let's just go ahead and print these out individually so we can see that it's working. So here's our key set, run that, and again, all of our keys. Let's instead print out our values. And here are the values. And notice that these are not in any particular order. So it's convenient that we have access to these two different views, but the real power of the hash map comes when we attach the key to the value itself. Like, I don't know what 4 means without the context of my key, Kayla. And if you think about how you might do that if you were designing your own hash map, is you might make a class within our hash map called, let's say, key value container. And I might just store then 2 values. One is a string, that is my key, and one is an integer, which is my value. And so this would allow me to store a string, Scott, and a value 1 in one container. So that would look something like this. Okay, so we have a container that holds our key and our value, and it turns out that this is a really oversimplified version of what's happening within the hash map. The hash map has something called an entry, and this also we have to define our key and our value. So it's going to be, in this case, string and integer. And let's real fast take a look at our entry methods. We have get key and get value. And this would be like if I were to just have some getters for this. Right? So this entry is an inner class within the map interface that is a container for our key value pair, just like this key value pair container. And of course, we have to define our type parameters for the key and the value because we don't know if it's a string and an integer. That's defined as we create it, which is what makes it so flexible. So that would look something like this. Key. So this key value container is now flexible and we can define our key and value types as we create it, just like the map entry. So how we end up using this most of the time is we would take our map and we would say entry set, which returns a set of all of these individual entries. So let's go ahead and store that in a set. And what is the type of the set? Well, again, it's these entries. So we're going to say map entry. And I again have to define my string and integer key and value. And now I have a set of all of these key value pairs. All right, so over here, each one of these is again an entry, a map.entry, an inner class within the map class. So here's an entry, here's another entry, and it represents a key value pair. So I have 5 entries, each is its own key value pair. So when I run entry set, I'm returning a set of all of these key value pairs. And if I were to print out this entry set, let's go ahead and rename this entry set because it's not an individual entry, it's a set of entries. And notice our entry set looks a lot like our hash map when we printed out the hash map. Let's go ahead and do that one more time, just the map itself. And here's the hash map. You can just see it has curly braces, whereas the set has square brackets. Now, we can't iterate over the hash map itself. Like I can't do a for each loop over the map because the map is, again, made up of these individual components. But I can iterate over any one of these sets or collections. So you'll commonly see something like this: for map entry of string integer, and we can call that entry, let's say map.entrySet. So this is saying our map entry set, which we know returns a set of our entries. So each one of these. Iterate through every item in this entry set. The items are of type map entry string integer, and that we are going to store in a variable called entry. So if we now just print out each entry individually, let's go ahead and run that. We can see we have our Jamie, Lena, Wells, Scott, and Kayla. But of course, because this is an entry, we have certain methods like get key. Let's print that out. We can do get value. There's all of our values again, and we can use both of these things in flexible ways. Okay, cool. So I went off screen and just kind of constructed a sentence where I'm pulling out the entry key, which is Jamie, Lena, Kayla, has the value 0 dogs, 4 dogs, 1 dogs. I would want to obviously remove that S in real life. And then I just complete the sentence, right? So this is pulling out the 2 sides of this map.entry inner class, both the value and the key, and using them in a sentence. All right, so hopefully that helps clarify what's going on under the hood of this map entry thing and why it looks so confusing when we're having to use all these type parameters and we're extracting different values. Once you understand that, this starts to all kind of fall into place. So now that we have a foundation laid, let's go ahead and look at some more real life use cases that you might come across. Okay, so on the right, I whipped up a quick employee class. It just has an ID, a name, and a department. And on the left, I have made a quick array list of these employee objects. Now, you can imagine that this list is a list of 1 million employees that you're maybe pulling from a database, and you might want to put them in a hash map to access them quickly in different ways. So first, let's try adding each employee to a hash map, and we want to use the employee ID as their key, so we could look up any employee by their ID and get all of their information back. So we're going to start with our map interface, and our key is going to be a string because the employee ID is a string, and we're going to go ahead and dump the whole employee into our value. So this is going to be, let's say, employee by ID map equals new hash map. So now I'm going to iterate over the employee list and build the hash map from it. So let's say we're going to pass in an employee, and we're going over the employee list. So this one's pretty simple. All I need to do is say employee by ID put, and I know each one of these is unique, so I can just say employee.get employee ID, and then I'm going to pass in the whole employee. And really, that's it. So again, we're putting the key here, which is the employee's ID, and the value is here, which is the entire employee. Let's go ahead and print that out and see what happens. Here is our employee by ID map. And you can see how hard this is to look at. This is actually why I made that other helper class that is going to let me print this out in a more legible way. So pretty print. And let's go ahead and print that out. So there, on the left we have our keys, which is each employee ID, and the value is the entire employee object. Now notice that the employee object also contains the ID, and that's not entirely unusual to have redundant information in our object and our key. That's totally fine. But now if any employee comes in and says, here's my employee ID number, we can look up the employee in constant time just by using that key. All right, let's try another one. Let's say we want to count how many employees are in each department. Notice we have a couple of departments here, and we're just going to count how many are in each one. So num of employees by department. So let's make a new map. The departments are all strings, so that can be a string. And we're going to use an integer here because we're trying to count something. So this can be department count map. So just like before, we're going to iterate over our employee list. Okay, so I rearranged a little bit here, and now this is going to be pretty similar to what we were doing when we were counting the dogs in the room, where we need to pull out the current value and then increment it. So let's start with that line of thinking, and of course our key is going to be the employees department. So this would pull out the current value if it exists. However, we know we're starting with an empty map, like I haven't put anything in this hash map yet, and if I run get on something that's not in the hash map, it's going to return null. So I have to first check to see if this key already exists in my map. And the easiest way to do that is to run this contains key method. Notice that it takes in a key and returns a Boolean. So let's go ahead and run that. And we're going to do that with our employee.get department. And because this returns a Boolean, I can wrap it in an if statement and do something if it exists. And I'm actually more interested if it doesn't exist. So if it doesn't exist, I'm going to essentially put it in, and then if it does, we'll do something different. So let's go ahead and add our first value. Let's put the employee.get department as our key, and our value is going to be 1 because this is the first time we are coming across this value. Otherwise, we are going to do something very similar to what we did with the dogs, where we pulled out this value, which this is of course an integer, so int num of employees. We then need to increment it, and we can put it back in the map with the incremented number. Now you've probably noticed that I've run this employee get department method a whole bunch of times. Let's go ahead and pull that out and put it in its own variable. So now I have the department in a string variable, and I can use that anytime I want to pass in the key. Let's go ahead and run that and see what we get back. So if I print out my department count map, let's go ahead and run that. Here's my department count. And again, I have the pretty print thing, so let's use that. There we go. So this makes sense, right? Because engineering has 2, stunts has 2, baby and barking have 1. All of this lines up and it looks like it works. And again, the big takeaway is if it doesn't contain the key, we need to handle that differently than if it already does. So this totally works, but I want to point out something that can help us clean it up a bit. I'm going to go back up to our simpler map so I can isolate a new method to introduce, and this is going to be get or default. And notice I can pass in the key just like a get, or I can define a default value. How this works is if the key is contained within the map, it will return the value associated with that key. If it's not, we can define a default value. So let's go ahead and print out these two gets side by side and see how they behave. So currently we have get and get or default, both passing in values we know exists. And they both give back 399. However, let's go ahead and pass in a key that doesn't exist. Let's go ahead and run that. And now notice that when we pass in a non-existent key to the get method, we return null. However, with get or default, I can define my default value. Now this is going to help us because here we don't have to check if it contains the key. We can instead assign a default value. So let's say this is approach number 1. And let's go ahead and refactor this using the get or default method. So department count map, I'm going to say get or default, and I'm going to pass in the key. And let's go ahead and keep using our department variable. So we're going to get the department. And if it doesn't exist, our default is going to be 0. So this is going to return that int num of employees. And again, we want to increment this. And then we want to put it back in the map with our incremented value. And so let's go ahead and run that and make sure this works like we expect. And we're getting the same values as before. And of course, we could get kind of messy with this. Like I could say this is get that in +1, so I don't have to increment it in its own line. I can take this entire get or default method, which I'm storing in this variable, and just pass it right into the value. So I can't even fit that whole thing on one line of code, but let's run that. And it's the same thing. So you could feasibly write this entire thing in one line of code. Obviously here I'm still pulling out the department, but I don't have to. Now, this is a trade-off of legibility, and like this is getting kind of hard to read, but it's an option. And the more familiar you get with HashMaps, the easier this will be to kind of parse through and understand what's happening. All right, let's do one more example where this time we want to have a list of employees by department. So to set that up, we're going to create a map. Our key is going to be our department again. So that's going to be a string. And instead of having an individual employee, we need a list of employees. Let's call this employees by department. And let's think about how we would add something to this list. Like if I said employee by department map, put, I could say, let's add engineer as the key. And here, like I want to add an employee to this list of employees, but what do I add here? I don't have a list of employees yet. So one thing I could do is create the list outside of the map beforehand. So real fast, I'm actually going to change this to string just for demonstration purposes, and then we'll switch it back in a moment. Let's go ahead and make a list of strings, and we'll just take the employee's name rather than the entire employee object itself. Name list. Let's add one more name to that. Okay, and now I can pass this name list in to my map. So let's go ahead and print that out. And that works. And again, let's use our pretty print. Cool, so that works. Over here, this is gonna look something like this, where we have our list of strings as our value. And the key is going to be engineer. So really these, maybe a better way to visualize this would be something like this, where the list is containing these values. Cool, something like that. Another way we could have gone about this is we could say employee by department map.put. Let's go ahead and add stunts. And this time, instead, I'm going to instantiate my list inside of this put method. And now, if I were to do employee map get stunts, let's think about what that returns. So first of all, we now have stunts and we have an empty list, right? This is where we are here. And when we say get stunts, this is saying, hey map, get me the value you have at the key stunts. So this is returning my empty list. And so now I have a reference to that empty list. I could store this in a list of string. And then I could add into it directly like this. Let's add Jamie and Wells. And actually, that's all I need to do. Let's go ahead and run this again. So notice, so here's stunts and here's engineer. So notice that I didn't have to actually put this back into my map because this returns a reference to the array list that is also being referenced from the map. So both the map and this variable are pointing at the same underlying array list. So when I add to it, it's reflected both in the map and in the list itself. This also means that I don't actually have to store this in a variable. I could directly add it like this. And I can actually do that one more time. And let's just add a different name so we can make sure that we are actually seeing a change here. And let's go ahead and run that. And notice this time we have Jamie Dresden, right? Because this, again, is returning a reference to the list. And then I'm saying add Jamie to that list. So this would be saying Jamie. And then I added Dresden. So armed with that knowledge, let's go ahead and build our hash map using our list of employees. So just like before, we'll just iterate over the list. And I'm going to go ahead and switch this back to the entire employee object rather than just the name. And like before, I think we'll get ahead of something here. We'll pull out the department from the employee so that we can use it as our key in multiple places. And now we could approach this like before where we use the get or default. So I could say employee by department, get or default. Let's pass in the department, and the default could be instantiating a new array list. So now that I have this, I can store this in a variable. Of course, this is returning a list of employees. So employee list, let's just call it employees. And now I can add to it. I'm going to add the employee. Now, if I run this, you might expect this to work, right? Because I have a reference to the list, I'm adding to it. Let's go ahead and run it and see what happens. And you'll see that actually it's empty. Well, that's because I never actually put an empty list into my map. I'm just saying, if the list exists, go ahead and give me that list back. If not, return an empty list. So in order to make this work, I would have to use my employee map put method again. And now I can put the department in there and the employee list that I just pulled out and add it to. So I think if I run this, this should work. And yeah, so there we go. There's each of these employees. We have one barking employee, two stunt employees, Jamie and Wells, an engineer, and a baby, right? So all of that should match up with this up there. Now this is a little messy because I'm either pulling out an existing array list or instantiating a new array list, and then I'm putting it back either way. So I don't love this. Another option would be to use a method called put if absent. So essentially what this is saying is if department is absent, meaning it does not already exist, go ahead and put a new array list in there. Now notice that this time I am indeed putting something in there. So no matter what, after this line, I either have an empty array list or there was already one in there for this key. So now I can simply say get the key, all right? So I'm getting the object at this key, and I can add to it because again, this is a list, right? So this is like saying, hey, engineer, get me the list you have there. And because I have a reference to that list, I can directly add my employee to it. Go ahead and run that, and it works the same. So that's perfect. I think that's probably the best way to go about building this type of list. But as you saw, we did this in 2 or 3 different ways, and it's super flexible, and knowing all these different tools and methods you have at your disposal is going to come in handy. All right, so that was a lot, but I hope that by starting with a foundational conceptual level of understanding, as we got into the more complex stuff, it was a little bit less intimidating and confusing. And like any good topic, this is a good jumping off point into other topics. I know for me, one of the first things I wondered about is how the heck are we accessing this in constant time? That seems impossible. It's using something called hashing, and I will get into that in future videos as I find it really cool and interesting. I'm going to clean this up a bit and put it on GitHub. Check out my HashMap printer. I'm pretty proud of that. And also, I'm still looking for my first job. So if you know anyone who's hiring, I would love to come build HashMaps for them. Thanks a lot.